Hello students, here I have come up with one more challenging problem in electrodynamics. The problem is like this, let me explain. It's a wire frame, and through this wire frame the magnetic field is perpendicular to this wire frame, but now the magnetic field is coming out. Perpendicular to the frame but coming out here. And also I have connected at one end of the frame, I have connected a battery with voltage, with voltage E. And here is a slider whose resistance is R and mass of the slider is M. But this slider, it is in the horizontal plane. It is not in this plane. We show it on the board and it gives a feeling that possibly it is on the board and it may fall down under gravity. But no, it is horizontal frame and the slider is also horizontal. Okay, what happens? This battery sends current through this slider. When it sends current through the slider downwards, because it's not moving, the slider is at rest initially. The slider is at rest and it sends current. The moment current passes through the slider, that current is in the magnetic field, is a current carrying conductor now in the magnetic field, and therefore there is a force on this slider because current carrying conductor in the magnetic field experiences force. But what's the direction of that force? The current is down, magnetic field is outwards, I cross B. The force will be in the forward direction. This is the force. The current passes like this, current is downwards, it is current like this, magnetic field like this, out, this is current. When you get I cross B, it will be like this. Force is in this direction. This is the direction of the force. Due to this force, the slider moves. When the slider moves, it cuts the magnetic field. And that cutting of the magnetic field creates induced EMF in the slider itself. That is due to the motion of the slider. जब slider move करेगा, तब जाकर ये slider magnetic field को cut करता है. Because of the Lorentz force, this end will become positive, this end will become negative. Because this is now the motion is like this. Motion is like this to the right side for me, and magnetic field is like this. Right? Now, V cross B, the charge will surge up according to Lorentz force. The upper end will become positive, lower end will become negative. So, there is additional EMF developed across this slider. Okay? But that potential difference is opposed to this potential difference. Therefore, current will reduce. So, what is our question? Initially, there is a force and the slider will accelerate. But after the slider accelerates and the velocity increases, this induced EMF will increase. And this induced EMF opposes this. So, current will decrease. And finally, what will happen to the velocity? It will go on decreasing. And finally, at some stage, the velocity will remain constant. So, what I have to do is, I have to find velocity of this slider as a function of time. What will happen to the velocity when it goes in the forward direction? It will certainly decrease. It will definitely decrease. Or what will happen to the velocity? Let us find out from the equations. So what will happen to the velocity, or how the velocity changes with time, that we have to find. So what should I do? First of all, when the current flows through here, the force is forward, and when there's an induced EMF here, now the current will reduce. Now there will be a net current. That current will be decided not by E. It will be decided E and the induced EMF here. So the current is I through this slider. It will be E minus VBL divided by R. That's all. Question number first. जो इसमें से current flow करेगा, that will be voltage divided by resistance. The voltage is E minus induced EMF here. That is VBL. E minus VBL by R will be the current. What is this force? Force on the net current now. That force is I L cross B, that is ILB. That force is equal to, what is I? That's E minus VBL by R into LB. This force is m dv by dt. Mass of the slider into its rate of change of velocity is equal to E minus VBL LB by R. That is separation of variables. I will get velocity terms to the left side and time term to the right side. So how to proceed ahead? How to proceed ahead? Okay. How to proceed ahead? It will be, yes, dv divided by E minus VBL is equal to, okay, this is MR downwards, it is LB by M into R, dt will go here, dt. Okay, now integrating both sides, what I get, so integration dv by E minus VBL is equal to integration LB by MR dt. Integrate from 0 to v because initial velocity is 0 when the slider starts moving, and initial time 0 le lo after any time. So equal to, it is ln of, because denominator contains v and ऊपर dv है तो ये ln हो जाएगा E minus VBL divided by डिनोमिनेटर का डिफरेंशिएशन डिवाइड करना पड़ेगा, दैट इज माइनस BL इज इक्वल टू LB बाहर MR बाहर dt का इंटीग्रेशन t अंडर 0 टू t लिमिट. तो इट इज, इस BL को यहां मल्टीप्लाई कर दो, इट इज ln ऑफ E माइनस VBL इज इक्वल टू माइनस B स्क्वायर L स्क्वायर बाय MR t. BL को भी यहां मल्टीप्लाई कर दो, ठीक है, मगर यहां पर जो लिमिट्स है दैट इज 0 टू v. ओके, नाउ सबस्टिट्यूट v फर्स्ट, दैट इज ln ऑफ E माइनस VBL, सबस्टिट्यूट एज v को v ही सबस्टिट्यूट कर दिया, माइनस अब v को 0 सबस्टिट्यूट करो, सो ln ऑफ E, only E, v तो 0 के साथ खत्म होगा, इज इक्वल टू, सो व्हाट इज हियर माइनस B स्क्वायर L स्क्वायर बाय MR t. ओके, नाउ अकॉर्डिंग टू लॉग रूल इट इज ln ऑफ E minus VBL by E, it is E is this applied voltage is equal to minus B square L square MR t. Okay, good. Okay, now it is ln to be shifted to the right side, so E वो anti-log होगा, E minus VBL डिवाइड बाय E इज इक्वल टू, ये एंटी-लॉग होगा यहां से E रेस्ट पावर माइनस B स्क्वायर L स्क्वायर बाय MR t. ओके, नाउ E को डिवाइड कीजिए यहां और यहां, दैट इज 1 माइनस VBL बाय E इज इक्वल टू E रेस्ट पावर माइनस B स्क्वायर L स्क्वायर MR t. सो फंक्शन ऑफ टाइम बन रहा है, सो इसको वहां लीजिए, इसको यहां लीजिए, सो इट इज VBL बाय E, इसको वहां लेने से पॉजिटिव होगा और उसको यहां लेने से नेगेटिव होगा, 1 माइनस E रेस्ट पावर माइनस B स्क्वायर L स्क्वायर बाय MR t. इसको शिफ्ट किया, इसको शिफ्ट किया, तो बताइए V किसके बराबर है? वी आर क्लोजर टू द सॉल्यूशन. V इज इक्वल टू E बाय BL, ये E बाय BL राइट साइड को लीजिए, E बाय BL इंटू 1 माइनस E रेस्ट पावर माइनस B स्क्वायर L स्क्वायर बाय MR t. This is the answer. This is the answer for the velocity as a function of time. It becomes exponential. So if you put t is equal to 0, this becomes e raised power 0, 1, 1 minus 1 is 0. So velocity has started with 0 velocity, because this will become 0 at t is equal to 0. So, but after some time, when t tends to infinity, after a long time, this becomes 0, this part. So what's the velocity? E by BL. So after a long period of time, finally, the velocity of the slider will remain constant. So first it accelerates, then finally the acceleration decreases, force decreases, net force decreases, and finally the net force becomes 0, acceleration becomes 0, and the slider moves forward with a constant velocity. And that velocity is this, E by BL. That's all. So this was one more challenging problem for you, but don't forget to watch my lectures, and I will continue to deliver lectures on challenging problems. These challenging problems are good for IIT students who want to aspire to appear in the advanced stage of the IIT, or those who want to appear in the international Olympiads or the national Olympiads. And this series, I think, will be very, very beneficial for the students. Thank you.